point P. If you release charge particle, it will not move along the red color path. Not possible. But exchange agent can move. I rolled a charge particle. You imagine yourself. I rolled it. I'll slowly move it from A to C. How much of work I should do? Okay, let's come for the potential differences. First, we'll calculate VAB. So to get that VAB, I think we need this diagram, no? This is 30. And we know this distance, 2√3 meter. There's a point A. This is B, this is A1. And there's a direction of E bar. So if you know if you know distance A1B, you multiply with E, you'll get the potential difference VAB. So cos 30.
Sir, 16, sir, work done.
Anybody? Somebody asking?
16, sir, work done.
Work done. Okay, fine, good. Yeah. Cos 30 will be A1B by AB. A1B equal to AB cos 30. Value of AB 2√3 cos 30 √3 by 2. So 3 meter. There's a distance AB. Then potential difference VA1B equal to E into A1B. This is 4. A1B is 3. 12 volt. Similarly, VCB is asking. First, we'll calculate VBC. C1 Newton. So this VA1B, no? So as we know, VAB potential at A is equal to potential at 1. So therefore, VAB is equal to VA1B. This is from previous conclusion. So now BC1 has to be determined. Cos 60 equal to BC1 by BC. Value of BC 4, 1 by 2, 2 meter. So therefore, VBC1 is equal to E into BC1. This is 4 into 2, 8 volt. So if you want VAC, that also you can calculate. VAC from here also you can bring it. Okay, now what about work done? How to bring the work done? Suddenly I'm asking work done. Here, I'll go back to the basic definition. What was the work done by electrostatic force in moving a point charge from A to B? There's one more. The very important thing which we are going to conclude. So I'll start everything. We know dV equal to minus of E bar dot dr bar. I will multiply charge on both sides. So what is that Q into E? What is that Q into E? Q into E should be the force, no? And Q into dV. So, and what is the basic definition? We brought expression for potential energy. Can you remember? Interaction potential of a charged body. So therefore, what is this Q into V should be? This should be the work done. So work done in moving a charged particle from A to B. By electrostatic force. So this is what I ended up. We'll do one thing. The RHS I'll replace it. So this will be F into d bar. You know what is F into d bar? Integral of F d bar. Work done by external agent or work done by electrostatic force in moving a charged particle from A to B. On this side, what you should write? Q into This is VA, no? Symbols, it is some missing. Huh? So this should be VA, VB. So this will be VB minus VA. Next, shall we write it? QVA minus VB is equal to, so what is the conclusion? Work done by electrostatic force in moving a charged particle from A to B. What is equal to? Just that what charge particle you're moving into potential difference. And we know work done by electrostatic force and external agent. How they are? Work done by external agent. Work done by external agent should be equal to QV into VB minus VA. Anybody, can you say why I changed it VB minus VA? Because work done by external agent, work done by electrostatic force. They'll be always equal and opposite. Because work done by external agent is plus delta U. Work done by electrostatic force is conservative force minus delta U. So from that is what I brought the relationship here. So now work done. So there's a one basic discussion here. So work done to move a charged particle from any point to any point. So what you should do here, just find out the potential difference between that point. Calculate the potential difference between that point. Now, what is our question? So I'll zoom in so that everything will be visible. Our question is to find out the work done by exchanging moving a charged particle from A to B. So do we know potential difference VBA? Sorry, this is C, no? Nobody observed the path. I'll make some changes here. Question, it has become B, it should be C. Let's modify the formula. So what shall I write? Work done by external agent in moving the charge particle from A to C should be equal to Q into potential difference VA minus VC. So I'll come back to the problem. Work done in moving a charge particle by an external agent should be equal to, what shall I write? VC minus VA. Do we know VAC? We don't know VAC, know how to bring VAC. We know VAB and we know VBC. From that we'll get the VAC. Okay, how to calculate VAC? VAC, can we write it as VA minus VB? VA minus VB plus VB minus VC. So VA minus VB is VBA. This is VBC. So what is VAB? VAB already we calculated. Is equal to 12. VBC. Where is the value of VBC? Here, 8 volt. $20 it is. Next, I'll substitute this one. So charge is 2. VAC is this much. VCA is how much? Minus 20. Minus 40 joule. I changed the path should be from A to C, no? But sir, he has moved in curved path. How come? It's not moving in something. It's moving slowly in curved path. Then an electrostatic force is also acting. You should overcome that electrostatic force such a way that the particle should not accelerate anywhere. So what work the electrostatic force does, equal and opposite work what E should do. Then only he can move slowly from A to C, from rest to rest. You go back to everything work by energy chapter. We have discussed all such numericals, if you can recollect. We have discussed many numericals based on this. There I didn't discuss, we discussed that some field. some force it is. So here that particular example of force you are seeing. Sir, how do you can say action agent still that one? So you have to move slowly from A to C. So electrostatic force will act, suppose here like this. Then the action agent should apply a force in such a way that or depend the particle, the acceleration of particle should be zero. Slowly from rest to rest, it will be moved. Infinitesimal displacement it will have. So what is the work done by electrostatic force? Equal and opposite work the action agent should do. That's what we took help of this. No other method available for us, because we don't know what is the nature of force the person will apply. Altogether, the work done we calculated. This is what needed for us in application. I'll just round off the answers. Where are answers here? Yeah. Okay, fine. So these are the some. So there can be any type, no path, anything, this one. So this is about the uniform field. So let's go for, sir, what happens if non-uniform electric field comes, what you are going to do? Let me straight away take some numericals here. Already we discussed in Volkmanji chapter, if you can recollect, many examples we have done. So there instead of force,